Welcome! In this video we're going to be proving quadrilaterals are parallelograms. We'll be determining if we're given enough information or what other additional information would be needed to prove a quadrilateral is a parallelogram. So let's go through the ways that, that can be used to prove that a quadrilateral is a parallelogram. Now, so first is the definition of a parallelogram. If both pairs of opposite sides of a quadrilateral are parallel, then we know the figure has to be a parallelogram. We also proved that if both pairs of opposite sides of a quadrilateral were congruent, that would also be a parallelogram. If one pair of, and we also proved if one pair of opposite sides of a quadrilateral are both parallel and congruent. So they do have to be one single pair of opposite sides and have both those characteristics, both parallel and congruent. We also proved that if the diagonals of a quadrilateral bisect each other, it would have to be a parallelogram. And then I gave you two other ways to prove a quadrilateral was a parallelogram using angles. So if a quadrilateral is a parallelogram, the two pairs of opposite angles are congruent, and it would have to be both pairs of opposite angles. And finally, if one angle is supplementary to both consecutive angles, the figure is a quadrilateral. The figure is a parallelogram. Excuse me. The quadrilateral is a parallelogram. I believe the first 5 are in your notes. I'm not sure that number 6 is in your notes. So if you can please add number 6 to your notes. All right, so now let's take a look. And you're going to want to have that. That'll help you have all the notes in your notebook because that'll help you do the homework. And we'll be doing an assessment at the end. And some of you will be taking AZ Merit, and all of you will eventually be taking ACT. So you'll want to know this information. Are you given enough information to determine whether the quadrilateral is a parallelogram? Explain. So here, notice that we have a pair of sides that are both parallel and congruent, and we just went over that in the last page, that this would be a parallelogram. So this is a parallelogram. I'm going to put parallelogram. Actually, I'll put it over here. Now I'll put the reason why. Right? We want to see how it says explain, and all we have to do is explain using the reasons. So parallelogram. This is the symbol for because one pair of opposite sides is both parallel and congruent. All right, so we can say that nice and short and succinctly. Number 2, is this a parallelogram? All right, so we've got these, oops, well, not where I wanted it to go. So we have this diagonal divided into two congruent parts. Right? And we have this diagonal divided into two congruent parts. That means the diagonals bisect each other. And we just learned, we just reviewed on the previous page, we learned earlier in the last video, that this would have to be a parallelogram. This is a parallelogram because both diagonals bisect each other. And it does have to be both. If only one diagonal was bisected, it would be a kite. 2 diagonals bisected is parallelogram. Right? So parallelogram because both diagonals are bisected. I forget which one of these problems are in your notes. I believe these are, because I gave away all my notes. Right? But when you see the problems in your notes, you go, oh, I should write those notes down. All right, how about this one? All right, so these two sides are congruent. These two sides are congruent. In the last video, we proved this, and we just saw it on the last page, that this would have to be a parallelogram because both pairs of opposite sides are congruent. So this is also a parallelogram because both pairs of opposite sides are congruent. And I bet you're already figuring these out before I even go over it. Sometimes these can be tricky, but these ones were pretty straightforward so far. Now this one might trick you. This is not like number 1. I have one pair of sides parallel and a different set of sides are congruent. All right, so none of these, by the way, are drawn to scale. They're just a quadrilateral, and some information is put in here. Well, having one pair of sides parallel and another pair of sides congruent, that's an isosceles trapezoid. Right? So the information we're giving, there is really a figure that looks like this, because we don't know that these sides are congruent. Unless these sides are congruent, that can't be a parallelogram. This would just be an isosceles trapezoid. Right? So not a parallelogram. Right? What's wrong with this one is that one pair, only one pair of opposite sides would have to be congruent and parallel. Right? So the markings show an isosceles triangle, or I could say markings apply to an isosceles triangle. Not isosceles triangle, excuse me, isosceles trapezoid. Markings apply to an isosceles trapezoid. And that's what I drew below it, all right? So they may, even though the diagram looks like a parallelogram, the information is really an isosceles trapezoid, because these are not drawn to scale. All right, so that one might have tricked you a little bit, right? But now we've gone over it. I hope it makes sense. All right, so we have some congruent angles. All right, so notice they are on opposite sides of this transversal. Right? This angle is congruent to this angle. That means that this side is parallel to this side. Now also notice that this angle, oops, it's kind of hard to draw it in there. This angle is congruent to this angle. Right? So that means that that pair of sides are parallel. Now, it's not enough for us to say that this is a parallelogram because both pairs of opposite sides are parallel, right? Because we weren't given that both pairs of opposite sides are parallel. We were given that the alternate interior angles are congruent. So when you're explaining, go back to what you're given and use that to show both pairs of opposite sides are parallel. Right? So this is very similar to a homework problem. All right, so this is a parallelogram. Because, or this is not a very good sentence, because since, maybe we should get rid of the because. And let's just put parallelogram and end that. It's a parallelogram. Parallelogram. Since both pairs, sometimes my sentences on these are a little run-on-y, so I'll try not to be run-on. Since both pairs of alternate interior angles are congruent, both pairs of opposite sides are parallel. And I could put making this a parallelogram, right? But I already put parallelogram up above, so it's all right. All right, now let's look at the last one here. Well, we don't have enough information because we don't know this angle. But could we find this angle? On the first lesson on parallelograms, one of the very first things I showed you is how to find the number of degrees in any quadrilateral, right? And we went over, so you don't have to write this part here, right? So 180 times n minus 2, right? And this is a quadrilateral, n is 4. 180 times 4 minus 2 would be 180 times 2, which is 360. So all quadrilaterals, the angles add up to 360. Right, so since we have that on the previous page, right, I'm just going to write in, we're going to just use the fact that the angles add up to 360. Right? So since the angles of a quadrilateral, and we could abbreviate that quad, right? That will not confuse anyone. since the angles of a quad add up to 360 degrees, I was almost going to say something else. 360 degrees, we're not on triangles anymore, we're on parallelograms. So since the angles of a quadrilateral add up to 360 degrees, the unknown angle equals 360 minus, we just subtract the other ones. So we have 60 plus 120. Right, so 60 plus 60 is 120. 120 plus 120 is 240. So the unknown angle equals 360 minus 240, which is 120. All right, so now we know what this missing angle is, and now we can see that this angle is congruent to this angle is congruent to this angle, and so that meets one of the criteria for being a parallelogram. Therefore, and we can abbreviate therefore, so this is therefore. It looks like because except the other direction. Therefore, both pairs of opposite angles are congruent. Actually, I can abbreviate opposite just to save you a little writing. Whoops, well, I picked up that too early. Here, I'm going to have to erase this. Both pairs. Oops, that wasn't what I had. I forgot my therefore. Therefore, got to match up with my pairs there. Both pairs of opposite, I should just wrote opposite, that was too much work to change, to abbreviate opposite there. Opposite angles are congruent. And there we go. All right, so all of these were parallelograms except number 4. That was not that's not information that shows that this is a parallelogram. That's information that shows it's an isosceles trapezoid. We would have to know that both pairs of opposite sides are parallel, or both pairs of opposite sides are congruent, or one pair of opposite sides is both parallel and congruent, like number 1. Right? But number 4, that doesn't work. Right? And I guarantee you there's a Palmer problem like that. So just saying. All right, now let's look at this one. Now these ones, we don't have enough information on all of them. It says what additional information is needed in order to prove the quadrilateral ABCD is a parallelogram. All right, so I have it written here 5 times. I think I have this one in your notes, so that we could show the information for all 5. There's one like this. It's the last problem in your homework. You'll draw out a figure based on the information that's given, and you'll mark it, and then you'll do exactly what we're doing, except you'll have enough information to prove it's a parallelogram, or you won't have enough information to prove it's a parallelogram. Right? If you don't have enough information to prove it's a parallelogram, you'll be doing what we're doing, and that is stating what else is needed. And if you have enough information to prove it's a parallelogram, you'll be doing what we did over here. All right, so let's try the first one. And I guess let's make this one number 7 right here. And then we'll go across. All right, so we're given AB is parallel to DC. Well, that's not enough information, right? So what else would what else is needed? All right, so one of 2 things actually would show that this is a parallelogram. All right, so either AD would have to be parallel to CB, and that would be both pairs of opposite sides are parallel. So you see, you want to be really specific. I didn't just say make both pairs of opposite sides parallel. I said which pair of sides would have to be parallel. Or we have one other way, or we could also have, right over here, AB, and I probably should put a little line over that. AB congruent to, because it is a segment, CB. Did I say the right ones? No, excuse me. AB congruent to CD. And then that would be one pair of opposite sides both parallel and congruent. Right? So either one of those things would work. Right? We'd either need, and you don't have to draw this, I'm just going to show you. Either these two sides would have to be parallel, or, let me get rid of it now. This side would also have to be congruent. Right? Either one of those would make that have to be a parallelogram. Because if they're congruent, then they're ending in the same spot, they're the same distance away, it's going to make the other pair of sides parallel. Right? So that was 7. Let's go on to number 8, and let's put 8 over here. Right? AB congruent to DC. Well, this is a lot like the other problem, right? Except this time we're given a pair of sides congruent instead of parallel. Right? So either AD would have to be congruent to CB, and that would be both pairs of opposite sides congruent. That would be the reason that would apply. Or, right, so we'd have this, right, so that would be a parallelogram. The other way would be the same as the other problem. These two sides would have to be parallel, and that would give us one pair of opposite sides, both parallel and congruent. And the one we were given, the sides were parallel. This one we were given, they were congruent. All right, so let's add the other thing that's needed. AB parallel to DC, and then you'd have one pair of opposite sides both parallel and congruent. All right, so that would be the reason that applies. All right, let's move on to number 9. All right, so angle DCA. So DCA is this angle right there. It starts at D, goes to C, and then head right to A. Is congruent to angle BAC. Start at B, go to A, continue to C. That's this angle here. All right, so now that tells us that we have one pair of sides parallel. So since angle DCA is congruent to angle BAC, since those angles are congruent, these sides have to be parallel because those are alternate interior angles. So AB is parallel to CD, and that's because those angles are alternate interior angles. So we're going backwards. We're going from the angles being congruent to proving the sides parallel. That's the converse of alternate interior angles. Right? So what else would be needed? We need the other pair of sides parallel. Right? So we would, and if the other set of angles, other set of alternate interior angles were congruent, then the other set of sides would be parallel. So what else is needed? Angle CAD would have to be congruent to angle, so that'd be CAD, that would be this angle here, would have to be congruent to BCA, this one here. Right, and then you'd have, those are alternate interior angles. Then we would have both pairs of opposite sides would be congruent. I mean, it would be parallel. All right, so the thing that's needed is that right there. We need the other set of alternate interior angles to be congruent so that we can show that the opposite set, both pairs of opposite sides would be parallel. All right? Because if this were true, okay, let me add, can I move that down? Oh, yes. All right, so I'll just put the little arrow here. If that's true, then the other pair of sides would be parallel. So that would be then AD would be parallel to CB. And then the reason that would apply would be both pairs of opposite angles, opposite sides would be parallel. Oh, yeah. All right, so let me just go over that one more time. Since angle DCA is congruent to angle BAC, AB is actually, I'm going to leave that the angles in there. That was the one, right? That was marked. Yeah. Since DCA is congruent to angle BAC, AB is parallel to CD, and that would be using the converse of alternate interior angles. If angle CAD was congruent to angle BCA, then AD would be parallel to CB, and then we'd have both pairs of opposite sides would be parallel. All right? Let's go to number 10. All right, so DE is congruent to EB. Oh, this one's a really easy one. All we need is these two to be congruent. All right, and then we would have both pairs of diagonals bisected. All right, so we need AE congruent to, oops, we have to make a congruent sign, CE, and then it would be, it still bothers me. Let me make that better. And then it would be both diagonals are bisected. That was one of the easiest ones. All right, done with that one. On to the last one. All right, angle CDA. So CDA, that's this angle here, plus angle DAB, that's this angle here, add up to 180. They're supplementary. They're not the same measurement. All right, so we need both pairs of consecutive angles. So we need one angle supplementary to both pairs of consecutive angles. So we need one of two things. We need angle CDA plus this angle here, right? That would do it. So angle CDA plus angle BCD equaling 180, right? That would work. Or we can use the other angle. We can go the other direction. We would need angle DAB. Oops, I forgot. When I pick up the array, I only can get purple when I do this, and I choose purple. Angle, I'm using a blue pen. Angle DAB plus this angle here, which would be angle ABC, equaling to 180. And then you'd have one angle supplementary to both consecutive angles. That's weird. That looks a little weird. I think I'm missing a letter there. I don't see the I. And there we go. There we go. All right. So we have solved these out. These weren't too hard. I think I'm going to do one more page. That's what was my plan. All right. So we're going to decide whether each piece of information is sufficient. And I believe you have this in your notes as well. All right. And then, boy, these are flying all over the place. Well, you know what? I'll work on getting these in a nice order. I think I'm going to have to put it back the way it was and just scroll the page. This is at 25 minutes, so I'm going to stop here. And in the next video, we'll do these problems. We'll go over the properties of parallelograms, and then we'll do a few more, all right? That'll just like this. All right, so we'll come back to this page in the next video. Thanks for watching. Bye for now.